Material science and engineering is a very unique discipline. It ranges from the atom to a device, or from the molecule to the application. Therefore, students that come to perform graduate studies here or postdoc studies here can come from different disciplines. They can come from chemistry, from physics, from electrical engineering, from mechanical engineering. By coming here, you actually get exposed to all of these disciplines on a very high level while you focus in your own research on what interests you. One focal point of the research in our department is energy and sustainability.
Green energy is essential for our survival here on planet Earth. My research deals with splitting water molecule using renewable energy in order to produce green hydrogen. This green hydrogen has a lot of applications, starting from replacing fossil fuels for transportation, energy storage for renewable energy such as solar and wind, and replacing hydrocarbon fuels in chemical processes. We developed a new process to produce hydrogen in a highly efficient way. And based on this invention, we founded a startup company called H2Pro. Basically the heart of the technology that H2Pro developed, and it was all done by my students. H2Pro is now commercializing this technology and is on the way to producing megawatt scale systems and essentially change the way that we use fuel in this planet.
You might think that materials are only solid materials, very hard materials, but actually most of the materials we use around us today are soft materials. For example, polymers. There are materials that are also designed to interface the human body and have to be flexible and soft, or are inspired by nature around us.
My group studies the interplay between tissue mechanics and diseases. One is looking at preterm birth. So we're trying to understand why preterm birth happens and how we could potentially catch it early. But we also have a lot of other people who work with, for example, protein-based materials, biomineralization, and trying to understand how different animals, develop their own materials and trying to understand the structure and the function. It's kind of the next frontier in material science research. Trying to tackle biological questions of material perspective allows for a lot of exciting opportunities. It's a new way to develop therapies, develop analytical tools, and for me, that's the most exciting aspect.
A major field in technology today is to develop quantum computing, computers that could process more data much faster.
When you think today what is needed in quantum technologies, the quantum physics is known. The electrical engineering and circuiting is known. The material is the missing piece to make everything work together to make real quantum devices and real quantum technology. The passion that I have, and my group also work in this way, is to look to a place that we know nothing, and gradually, step by step, we pave the way and we try to understand how the world around us behaves. And if you are brave enough, you can also use this science that you found for new technological inventions. It's a lot of work, it's a long duration of the work, but it's very rewarding when you succeed.
The science of the 20th century saw two huge leaps in the field of material science. One is the synthesis of new materials. The other are the electron microscopes, our ability to see the order and structure of materials on the atomic level.
My field of research is nanomaterials. We're looking at the smallest pieces of matter you can actually make in the lab. The materials we study are a new family of semiconducting materials. These are called lead halide perovskites. The Microscopy Center in the Faculty of Material Science and Engineering is equipped with the best microscopes in the world. I'm standing beside the Titan. The Titan is a dual-corrected transmission electron microscope that allows us to see sub-nanometer resolutions. We actually can see the atoms themselves. We can see the structures, we can see grain boundaries, we can see interfaces where two materials meet together. Essentially, we can really engineer them one atom at a time. This really makes you feel that you understand and engineer materials at the top level you can really get.
Our graduates find their place afterwards either in the industry or in academia, heading and spearheading many of the high-tech industry in Israel. Some of them even open their own startup companies that are very successful coming from the startup nation. We also happen to have a Nobel laureate on our faculty, Professor Danny Shechtman.
The main point of Technion is the entry of the world of research.
It's a bridge to the Western. If you have the dream to be a scientist, it's a good choice.
In this 2.5 years, I was able to publish 12 papers in high-level impact factor journals.
I'm from Canada originally. I really wanted to study something that helps other people.
It is a diverse country. You have deserts, you have mountains with snow where you can do skiing, you can go to the beach, you have a lot of national parks.
Israel is like being there on the edge, even in the food. Like something new is like colorful and some crazy mixture of food. Wow, it's about Israel. The same about the research and about the discovery.
You need only the motivation and the strong desire to pursue the science and the curiosity. If you have it, I think it's one of the best places to pursue your career here.
Graduate school and postdoc are the springboard to your career. It's a key to your success. It opens the door to your bright future.